All right, so the second part, now that we know how to write ratios, we're going to look at how to solve what's called a direct proportion. So I'll define for you what a direct proportion is. So a direct proportion is two things that are directly related. So if one quantity increases, the other quantity increases. So for example, the more vehicles a company owns, the higher the maintenance bill should be. The less vehicles you own, the less the maintenance should be. Another example might be on a blueprint. The longer the line is on a blueprint, the longer the wall is going to be, or that measurement's going to be in real life. So they're direct. They move both of them in the same direction. Okay, so we're going to look at indirect proportions after this one, but for now we're going to deal with direct proportions. So the first thing we're going to do is we're going to algebraically solve them, and then we're going to set up some word problems using direct proportions. Direct proportions, I think, are the most common ones you will see, and they're the ones that you really need to understand. Indirect proportions, you can get away with it if you happen to screw them up a little bit, unless you're dealing with gear ratios. But knowing how to solve direct proportions is going to come up in numerous applications. And it's a really good basic starting point for refreshing some basic algebra. So what is a proportion? Apparently I can't even write today, so you'll have to excuse me. A proportion is an equation that says two ratios are equivalent. I'm not sure what the extra on is in the middle of there, but anyway, I must have changed trains of thought. So we'll often use proportions to show scales. I just grabbed this from model cars. Those are common scales you would see. We'll see scales in blueprints, and because of proportions, we can figure out what the actual measurements are going to be. So first thing we need to do is we need to know a little bit of proportion algebra. So if we can do the algebra, then we're going to be able to solve the word problems. If you can't do the algebra, we're going to be screwed, quite honestly. So for proportion algebra, if a proportion is true, when you cross multiply, think of making an x in the middle. So if we take 8 times x and 7 times 15, if we multiply across, they need to be equal. So let's say, for example, let's do a test. So a half, we know a half equals 2 quarters. So 2 times 2 is 4. And 1 times 4 is 4. 4 equals 4. So the two cross products equal each other. I don't know if cross product's the right word in there. I feel like I'm using another math term. But so if you multiply across the equal sign and you're going to go opposite corners, you should have equal numbers. So we're going to do that down here. We're going to do a little bit of rearranging. So we're going to do this one. 7 times 15 should be equal to 8 times x. Now I typically won't use a multiplying sign in here because it gets confusing with that x. So you'll typically see me go 7 times 15 equals 8x, and that just means I've multiplied them. In your calculator, we'll plug in 7 times 15. 7 times 15 is going to give us 105 equals 8x. Now we need to get this x all alone because we want to know what is the number that belongs in the bottom here. In order to solve for that, we will divide both sides by 8. So it's 8 times x. The opposite of multiplying is dividing, so we're dividing. That cancels these two out, and we have x equals 13.125. Now I've kept the extra decimals there. If you wanted to say x equals 13, I could accept that given the fact that there's no decimals here in the answer. I haven't been very good at telling you where to round in this PowerPoint, so we're just going to use a little bit of logic to think about what would make sense. Any more than 3 decimals is not typically realistic. Okay, so let's do a couple of other questions just to kind of practice up. So we're looking for what is the value of n, so n is our variable. So we're going to do 16 times 72 is equal to 36 times n. 16 times 72 leaves me with 1152 1,152 is 36n. And then divide both sides by 36. N is equal to 32. Jumping over to this one, same thing, 42 times 64 is equal to 24x. 24 times x. 42 times 64 leaves 2,688 equals 24x. Divide both sides by 24 to cancel that out. So we want to get x all alone. So x is equal to 2,688 divided by 24 leaves us with 112. All right. Same thing, exactly the same process when you have decimals. So 2.5 times 12.4 equals 51.2. B. Make sure you know how to do this kind of algebra. If this is the only kind of algebra you remember from my course, I can live with that. I can live with that. It's not ideal. You're going to have to know some more algebra than this. But if this is the only one that sticks long term, you're going to be able to calculate a lot of things. So make sure you know how to do this one. So multiplying these ones out, I didn't write out the middle step. I'm just going to give you the final answer. So your final answer should be B equals 0.6. I've only kept one decimal place because there's only one decimal place in the answer here. So that kind of makes sense. So give this one a try. Make sure you can get that 0.6. You can follow the steps from before. Pause the video if you need to pause for a minute to calculate it. And then for the next one, 7.5 times 0.25 equals 1 times z gives me z. 7.5 times 0.25 leaves us 1.875 equals z. And you can use 1 or 2 decimal places for that. Would make sense for us. All right. So pretty easy algebra for us to do. Now we're going to do a few word problems. Nice, easy word problems. We're going to bring back the fruit bowl again. Oops. All right, so in this example, if the fruit bowl is filled using the same ratio of oranges and apples, how many oranges will there be in a bowl with 50 pieces of fruit? So let's look at what our numbers are in our question, what we want to find and what we're missing, and then we're going to see, do we have enough information to write a ratio that has those pieces in it? So first of all, how many oranges? I want to know oranges, so I'm going to say I have X oranges. Okay, so how many oranges? That's one of our pieces. Will there be in a bowl with 50 pieces of fruit? So 50 pieces is the other, and we have 50 pieces total. Okay, so there's the information that we know. Is there a ratio that we can write using the information from the graphic that has oranges to total? Well, there is. We know there's 4 oranges to 5 pieces of fruit altogether. So that's going to be equal to X oranges. So I notice there's 4 oranges. I'm going to line the X up with the oranges divided by 50 pieces total. Sometimes it can help to label them to make sure they're matching. And well, this is an easy one. We don't even have to hardly cross multiply on this one. 5 to 50 is times 10. So 4 to X is going to be a times 10. So we must have X equals 40 oranges. Okay, 40 oranges and 10 apples. Sometimes it helps to have something you can actually visualize and count. So sorry, it's an easy question. Maybe feels a little bit elementary with it, but sometimes that helps it stick for us. All right, let's do example 2. We've seen this graphic already, so you know how to write the ratios for it. We wrote several ratios for it already. So how many milliliters of soap will you need to make 5 liters of the soap solution? So I want to make 5 liters total. And I want to know, okay, if it's 5 liters total, how much is the soap? So let's list our pieces. So I have 5 liters total, and I have X mils of soap. Now, it says there's 5 parts of water, 1 part of soap, so there's 6 parts total. And parts all have to be in the same units. So that means this 5 liters needs to be converted to maybe milliliters. So let's say it's 500 mils. 5 times 1,000 gives us 500 mils. So let's set up our ratio. So we know there's 1 part soap to 6 parts total. And that's going to be equal to X mils of soap over 5,000, 5 liters of our total solution. So we're going to do our cross multiplying. 1 times 5,000 gives us 5,000 equals 6 times X gives me 6X. Divide by 6. And X is equal to 833. Now you'll notice here there was mils beside this X. So we're going to have milliliters of soap. Weed killer for the lawn or different cleaning solutions. This is not an uncommon type of math to do. Fertilizer often gets mixed up this way. All right, so it's a nice, easy ratio to do. But again, you have to kind of stop and think. The picture didn't tell us how many parts there were in total. We had to do a little bit of math to find that. So watch for those questions. There will be a few of them, maybe not as many as some of the other ones, but you'll get a few of those questions where you have parts in total and you kind of have to think about how it all goes together. If you need 833 mils of soap, it would be very easy for us to find out how much water. You just take your total of 5 liters and you subtract your quantity of soap. All right. Quick ramp question. A standard wheelchair ramp, this is from the code book, should have a grade no steeper than 1 to 12. That means for every inch of rise or change in height, there should be 12 inches of run or change in length. If a door is 2 feet 6 inches above the ground, how long would the wheelchair ramp need to be in feet and inches? Sketching a diagram often helps, so we'll sketch a diagram for this one. So here's my ramp. So this height is 2 feet 6 inches, or we could say it's 2.5 feet. And we want to know how long, basically, where would the end of this ramp sit from the building? So how long is this distance? Okay, and we'll wait till we get to trig to find out the diagonal measurement of that ramp. But for now, we're just looking for this measurement here. So the question tells us that the ratio of rise to run, so rise is up and this is run here. So the ratio of rise to run has to be a 1 to 12 ratio. Okay, so if we have a 1 to 12 ratio, rise to run, rise is the 1, so let's look at our question. Well, we know that this ramp has to go up 2.5 feet, so that's going to be a rise, so we're going to match that with rise. And then our run is what we don't know, that's going to be our x. So x, 1 times x, is going to be 12 times 2.5. X is equal to 30 feet. So 12 times 2.5 gives us 30 feet altogether, and no inches. It's one of those questions that sometimes just saying how many feet and inches are there can kind of throw a person because you're expecting there to be inches, but there's actually not. So it's just 30 feet, no inches. Another type of question you could see is something like this one. A 4-inch level is placed on a steel shaft. When the level is level, sounds like a tongue twister, there is a 50 thousandths of an inch gap between the level and the rod. So I've got that drawn in here. This diagram's a little tight, so we have 50 thousandths of an inch space in here. How high must the shim be under point B? So we're going to put something under here in order to bring this end up, because we want this end to hit level on the other edge. Okay, so we want to bring B up to level. So we want to know, well, how much am I going to have to place under here in order to bring the shaft up to level? And we want to round our answer to the nearest thousandth inch. Now, triangles, if they share the same angle and side, they are directly proportional. So these are two triangles. So we could say the little triangle in here and the big triangle in here are proportional triangles because they both have 90-degree angles here and they share this angle. All right, they're also lining up, two sides are shared as well. So this is just a small version of this triangle. So that's not quite, this one's not quite twice as big, but you kind of get the idea, okay? So that's what's happening with this question. So if we look here, we have a 4-inch level. So this distance here is 4 inches. So I'm going to draw a little triangle here. So we have a very small triangle. It's 4 inches long and 5/1000ths of an inch high. I want to say, well, if we could make that triangle extend it out further, what would be this height that we have to lift that shaft? Okay, we want to know how much difference is there. This is not too complicated to do. We could do it leveling a deck, leveling a shaft. This is kind of more machinist oriented. So we know that for 4 inches of run, there's a drop of 0.050 inches or 50/1000ths of an inch. That same ratio has to be true of the whole shaft. So if it's 4 inches on this length, well, we're going to find what's the other measurement that corresponds in the same direction. Well, that's our 13 1/4. And I'm going to put it in decimal form because we know that we're going to have to do some calculation, and it's often easier if there's decimals in other places in the question to put everything into decimals, especially when they're easy decimals. And x is our height over here. So we're just going to do some basic multiplying. So 50/1000ths times 13.25. I'm going to pull out my calculator since I just wrote a final answer. 13.25 times 50/1000ths gives us 0.6625 is equal to 4 times x. Divide both sides by 4. And we find that x, let's cancel out, is equal to 0.166 inches, or 166/1000ths of an inch. That's a proper way to say that. Okay, so 166/1000ths of an inch, and it was inches here, inches there, inches on the bottom, so we knew this one should have been inches as well, otherwise our units wouldn't match. So pretty easy calculation. It's not too bad in order for us to be able to solve. So we would have to put a little shim that's 166/1000ths of an inch, and we could take that and convert that to how many 30 seconds or how many 64ths need to go under there, but we'll leave that for now. I don't want to keep you too long in these videos. A fifth example, this is a good easy one. This one should make your brain work a little bit less. Maintenance on 7 trucks for 1 year costs $870. What would the maintenance cost on 9 trucks for a year at the same rate? So 7 trucks costs $870. That's equal to 9 trucks at X amount of dollars. Notice trucks and trucks on the top, dollars. So we're going to have dollars on the bottom over here. So we're going to get 7X is equal to 9 times 870. And if you rearrange that a little bit, you divide both sides by 7. Multiply, then divide by 7. We'll find X is equal to $1,118.57, or $1,119 if we round to the nearest dollars. That means no decimal places. Okay, so pretty easy question. And the very last question, if you're in a blueprints class, you will see this one show up in blueprints. If you don't have a blueprints class, which I know automotive doesn't, you won't have seen a question like this, but it's a good review kind of question. So this model car is on a 1 to 18 scale. The model is approximately 10 inches long. I want to know what is the actual length of this car. So it's given the scale and the length of the model shown in the diagram. What's the actual length of the actual car in feet and inches? So let's write out our ratio, and I'm going to write it as a fraction. I find it easier to think of them as fractions. So which number is the length of the model? Well, the model should be smaller than the car. So we must have logic would tell us the model is the 1 and the car is the 18. Okay? Unless somebody's scaling cars up to do some kind of monster thing, that's what makes sense using some logic. So that means if we're going to put, so that's our scale. If we're going to put in our measurements, we need to put the model on top and the car on the bottom. So 10 inches, and you could set it up reverse. You could flip it over. As long as you flip both things over, you'd be okay. So the model was 10 inches long. So the actual car is how many inches long? Well, let's figure it out. 18 times 10 equals x, so 180 is equal to x. So 180 inches, and 180 inches divided by 12 leaves us with 15 feet long is the car. And again, we have no inches on this particular question. And that finishes off direct proportions. Next, we're going to take a look at indirect proportions. So related quantities, but when one quantity increases, the other one decreases. So that's going to be our next section.